we obtain the value r squared, which is how much of the variability of the variable y is explained or accounted for by the regression line. Now that value is related to the correlation coefficient, and I'm going to show that later. But now I want to show another important aspect of the correlation, which is the slope of the regression line. Now, what I'm going to show here, you need to take it very carefully, because the slope of the regression line is what we typically associate with the correlation coefficient, but it's actually there is some relationship between the slope of the line and the correlation coefficient, but mostly the correlation coefficient has to do with the variability, how much of the variability of the data is explained by the regression line. So let's explain in more detail. So that's the red regression line, and when the regression line is at the mean of y, that correlation is a correlation of 0. There is no relationship between x and y. For every value of x, the value of y is the same, is 50. So there is no relationship between these two variables. If I start rotating that line, and remember that it always goes through the mean of x and the mean of y. Now, when that line becomes the 45 degrees, then there is a tendency for the correlation coefficient to be 1, to be a perfect relationship. The closer the line goes to this 45 degrees line, the less likely that there is a huge variability in the data, and the close the correlation will be to 1. If we keep rotating, again, the correlation between these two variables is 0. So that means that the only value we observe in x is 50, and in the variables, the values in y are in the range from 0 to 100. So we move from 0 to 100 in y, and there is no movement in x. Therefore, these two variables are not related. If we keep rotating, now the relationship between the two variables becomes negative. That means that for higher values of y, we have lower values of x, and for lower values of y, we have higher values of x. And again, this is in the 45 degrees at a 45 degrees angle, and that tends to be a perfect negative correlation. And if we keep rotating, we return to 0. Now, this is a tendency that's not a certainty, because, as I said before, the R value has to do with the amount of the variability of y that is explained by the regression line. As you saw before, if there is a difference between the dots and the line, the red line, the regression line, this will reduce their amount of variance accounted for by the regression. So that's what I'm going to explain now, the slope and the residuals. So here we've got a line, the red line, the regression line, and all the dots are on the line. So when that happens, the regression the correlation coefficient is 1, a perfect relationship between x and y. Here the regression line is the same as in the previous example, but as you can see, the orange dots are far away from the regression line. So therefore, we will have that the variability of y is not fully explained by the regression because there is a distance between the orange dots and the regression line. So even though we've got we can see that at higher values of x you observe higher values of y, and the relationship seems very strong, the R score or the correlation coefficient will be different than 1 because the distance from the dots to the regression line is quite large. In this example, we've got no distance, and this is the tricky one. There is no distance between the dots, the orange dots, and the regression line, which in this case coincides with the line of the mean of y, but the correlation is 0, even though there is no separation between the dots and the regression line. And finally, in this case, we've got a regression line and all the orange dots are in the line, so there is no distance between the observations and the regression line. So that means that the R score is 1 because, as I said before, the main component of the correlation coefficient is the separation between the regression line and the observations, and because there is no separation, the correlation coefficient is 1. But as you can see, the slope of the regression is not steep at all. So yes, it is a perfect relationship between x and y, but when you go from 0 to 100, there is a constant increase of y, but the increase is very, very small. So would you say that there is a strong relationship between x and y? Well, there is a strong relationship in the sense that we can predict perfectly by knowing the values of x what value of y you will observe, but the relationship is not very strong in the sense that a huge increase in x leads to a small increase in y. But for the correlation coefficient, this will be a correlation of 1.